Hello everybody, welcome to this next video on functions. In the last video, we saw what is the meaning of a function, what is the mathematical definition for a function, and we also saw at some of the tests which we can apply to test whether a given relation is a function or not. So in this video, we are going to do some practice questions, right? So I have taken them from the Nelson book. So here you see determine which equations represent functions. So we are given three equations. Y is equal to 2x minus 5. Then you have x square plus y square is equal to 9. And then you have another one, y is equal to 2x square minus 3x plus 1. So we want to know out of these equations which one is actually representing a function. So what we have done here, you can use your graphic like calculator to draw the graph, or you can go for Desmos. So here I have drawn the graph for this particular equation, y is equal to 2x minus 5. So here is the graph. I saw that this is a line. This is a line with, slope is equal to 2. Okay, so let us just draw it on Desmos. When you draw it on Desmos, this line you will get. Now I have to see whether it is a function or not. So we know that to test whether a given relation is a function or not, we can go for a vertical line test. Here I can keep on drawing the vertical lines, right? And I see every vertical line is intersecting the given graph only at one point. Can you see that? The intersection point is only 1. Okay, so we can write that every vertical line is intersecting the given graph, only once. The given graph only once. Therefore it is a function. So it means that the equation, which is y is equal to 2x minus 5, is actually representing a function. And there is another way. If you don't want to draw the graph and if you don't want to use the vertical line test, so you can use the basic definition. What is the function? We know that function is a relation, so that for every value of x, you get exactly one value of y. So here you see, if I just give x any value x1, then we know that 2x1 is unique and then minus 5 is unique. So for any value of x, I am going to get only one value of y. For example, if I give x is equal to 0, I am going to get 2 times 0 minus 5, that is minus 5. So corresponding to x is equal to 0, I am just getting one value, that is minus 5. So you can test x is equal to 1, corresponding to x is equal to 1. You get 2 times 1 minus 5, that is 2 minus 5, that is minus 3. But obviously we cannot test for all the values of x. You cannot do it like that. You put all the values of x because there are infinite values of x. But from the relation itself, you can see that there is only one value of y for every value of x, right? So what we want for a function, we want that corresponding to every input value, we should have only one output. We cannot have more than one output. So here, if I put here one value of x, I am going to get a unique value of y. So that is why it is a function. So it's your choice. You can either use the vertical line test, which I have done it here, okay, or you can use a theory like this. You can see whether for one particular value of x, are you getting two values of y anywhere. If that is the case, it means it is not a function. Okay, so let us look at the second equation. So second equation here is x square plus y square is equal to 9. So again, I used the graphic toolbox, right? So I have drawn it here. You can use Desmos. So here, this is a circle with center 0, 0 and radius 3. And you can see if I apply my vertical line test. So if I draw a vertical line, so you see, I can see 2 points of intersection. Okay, so vertical line test says this is not a function. So it's not a function because we are getting 2 points of intersection. You can get more than 2 also. For example, if I have some graph like this, okay, if I draw a vertical line, I get 1, 2, 3, 4, 5 points of intersection. The only point is we should get more than one point of intersection. So this is not a function. And now we can try seeing another way. Like for example, I have x square plus y square is equal to 9. From here, you see y square is equal to 9 minus x square. So if I take this square on the other side, I take square root on both sides. So I'll get y is equal to plus minus square root of 9 minus x square. So it means that when I say x is equal to say 3 or 1, so what values of y we will get? We will get plus minus 9 minus 1. So we get plus minus 2 root 2. So corresponding to one value of x, we are getting two values of y. So that is why it is not a function. Okay, so you can use the vertical line test as well as you can use this theory, right? So now let us look at the third equation. Third equation is a quadratic. So you have y is equal to 2x square minus 3x plus 1. So if you look at here, y is equal to 2x square minus 3x plus 1. So if you use Desmos and you try to plot, this is a parabola. This is an upward parabola like this. It keeps on going, right? Now if you draw vertical lines, you can see in the vertical line test, everywhere you are getting just one point of intersection, right? So this is a function. So a vertical line test, this is a function. This is a function, right? So you can also test by the other theory which we were using. Here you have y is equal to 2x square minus 3x plus 1. Now you see, if I insert one particular value of x here, so I'm going to get only one value of y. There we were getting two values of y because it was a square, y square. So that was giving you two values of y. But here you have a single power of y. So you get exactly one value of y. So that is why it is a function. So that is how you can test whether given an equation, whether it represents a function or not. I hope you understand. If you have any doubts or any queries, just write in the comment box. I'll be happy to help. Now you see, state which of the relations are functions. So I have taken this particular example here. So here, like last example, we were given equations. Now we have to see whether it is a function or not. Okay, so here you see, you draw your domain set and range set. So domain here is -5, -3, -1 and 1. And the range here is 1, 2, 3, 2. So 1, 2, 3. We don't have to repeat. So here C corresponding to 1, you have 1. Corresponding to -3, you have 2. Corresponding to -1, you have 3. And corresponding to 1, you have 2. Okay, so here you see, corresponding to every input value, you have exactly one output. Can you see? Corresponding to -5, I have only 1. Corresponding to -3, I have only 2. Corresponding to -1, I have only 3. And corresponding to 1, I have only 2. So corresponding to every input value, I have exactly one output value. So this is a function. So this is a function. Yes, it is a function. And if I ask you what is the domain, so domain is this. So you can write domain set for this will be -5, -3, -1 and 1. And range will be 1, 2 and 3. Okay, so this is how you see. And now look at the second example. Here already the Venn diagram is plotted. So here you can see, corresponding to -1, you have -3. Corresponding to 1, you have -3 and as well as 0. So corresponding to one input here, you have two outputs. So this is not a function. This is not a function. Okay, now let us look at another one. Here you are given this relation. So we can say 0. These are the inputs, 0, 3, 5 and 0. 0, 3, 5. And what are the outputs are 4, 5, -2 and 1, -2 and 1. Now you can see, corresponding to 0, you have 4 as an output. Then you have 3 and 5. Corresponding to 3, you have 5. Corresponding to 5, you have -2. And corresponding to 0, you have 1. So here you see, corresponding to one input here, 0, you have two outputs, 4 as well as 1. So this is not a function. This is not a function. Okay. So now similarly look at the another example. Here corresponding to -4 you have 1, corresponding to -2 you have 1, corresponding to 2 you have 1, right? And corresponding to 5 you have 6. But here corresponding to 1 input you don't have 2 outputs. So this is a function. This is a function. Is that okay? Now I think it should be clear to you that for checking whether a given relation is a function, the only thing you need to check is whether corresponding to one input you have exactly one output or not. You cannot have more than one output corresponding to one input. But you see, you can have corresponding to multiple inputs, you can have same output. That is not a problem. The only problem is corresponding to one input, you should not have two outputs, right? Okay. Now the next question is, use the vertical line test to determine which graphs are functions. So I have, this is the graph given to us. We have to check whether it is a function or not. I want you to stop the video for maybe 30 seconds and try yourself whether it is a function or not. So see here if I draw a line right here. So if you have already got the answer, you can write in the comment box before checking what is my answer. So see, I can draw vertical lines, right? I'm drawing a vertical line here. So this is the point of intersection, right? So can you see, do you understand what is a graph is? Graph is that corresponding to these values of x, these green dots are the values of y, okay? So I have corresponding to x is equal to 4. This is the 1 point. So I get only one output. Let me draw a line here. So if I draw a vertical line here, so I'm getting another output here. If I draw a vertical line here, you see you get 1, 2, 3 outputs. So corresponding to one input, you are getting 3 outputs. It's not a function. Okay, so if anywhere you get that corresponding to one output, input, you get more than one outputs, then straight away you say that this is not a function. Now look at this graph. If you draw vertical lines, I can draw arrow means this is never ending. It's like going on both sides, here as well as here. So now if we draw vertical lines, right, keep on drawing the vertical lines, and you can see that we get only one point of intersection everywhere, right? So this is a function. So by vertical line, it is a function. Okay, and this example here, you see, if I draw vertical lines, if I try drawing vertical lines, can you see I'm getting 2 points of intersection everywhere. I'm getting 2 points of intersection. So it's not a function, not a function by vertical line test. Okay, so this is the last example. So the question is, describe the graphs of the relations y is equal to 3 and x is equal to 3. Now you have to tell whether these are functions or not. So let us draw the lines. So you have y is equal to 3. So this line is like this, y is equal to 3. So can you see, is it a function? Yes, if you draw vertical lines, okay, you see corresponding to each vertical line, you have only 1 point of intersection. So what is the domain? So yes, this is a function. And what is the domain? Domain is whole real line. So we write it like this. And what is the range? Can you tell me what is the range? So see, you are getting just 3 as your output. Corresponding to each value of x, your output is 3. So the range is only one element, that is 3. And now let us go to the next line, that is x is equal to 3. So how do you plot the line x is equal to 3? So suppose this is my x-axis, this is my y-axis, this is x is equal to 1, 2, 3. So x is equal to 3 line goes like this. So now I ask you, is it a function? Corresponding to 3, you have so many outputs, you see? So corresponding to 3, you have so many outputs. So it's not a function. It's not a function. Okay. So this is how you test whether a given relation is a function or not. So I hope you understand it. Keep on practicing, and you have any doubts, you can write in the comment box. Thank you for watching. Please share this video and subscribe to this channel.